So, as an addition to my column videos, I will make a little video, or a little, I hope it's little, of the geometry nodes that I use for not only to create the column, as you can see here, but also to generate the detail sheet, which you see here. And let me change the background a bit. So it's like a 2D detail sheet of all the amounts and sizes of the column. I have another video about this. You can see it in the description. So, but today I want to focus on the geometry nodes that I've used to create this this column and this sheet together. Obviously, everything is around this menu. Is organized around this menu. These are the parameters that we use for the column, like which type of column it is, the style, the colors, if it's transparent or not, what kind of profiling that we use, and so forth. So in the other videos you can see how that works. But here I want to show you how it is done. So to do that, I'll go first to the highest level of groups, because I use groups a lot, and I sort of you can go down in levels to see more details. So perhaps I have like 7 or 8 or even more levels that I use of groups. So this is the top group, and in the top group it's important to see that you see, it's important that you see two different parts. You see this part, which I called ignore CSV data, and this part here, which is called use CSV data. So what is it all? What is all about this CSV data? In the future, I will make a video about combining columns and other 3D objects in one building file. That will be a separate Blender file where, let's say, applied column. So when this column is designed to your liking, then you can apply it, you copy it, and then you bring it to another file where you can work further with it. And that's because if I would use all these node groups, all these procedural node groups in one file, the file will get too slow very, very quickly. And by applying it, the speed of the construction, let's say the building file, where all the objects are combined, will be much, much faster. So it's a performance thing, and I already got quite a fast computer, so I already know that some computers already cannot deal with the node group that I'm creating here. But to me, this is sort of the minimum the minimum setup you should create for assets like this. Because I think that materials should be included, different styles should be included. Otherwise, you get way too many asset files. So it's nice to sort of reduce the number of asset files, and you do that by giving more functionality into one asset setup. So here you can see this, and these CSV data, what it does is that it is sort of a description of all. It's like a recipe. So when you set the menu to all kind of values, then these values you can also bring them to one short string. So you can imagine that a column that uses quite a lot of data can be, let's say, represented by a very short string, and that is very helpful if you want to copy that to, for example, Excel sheets, and where you, for example, make cost calculations of a building, and you have all these objects, all these different objects. Perhaps you have 200 columns with 6 or 10 different types of columns. Then it's nice to know, okay, this column with this recipe results in this amount of cement and this amount of paint and things like that, and that you can recreate that specific column if you don't really know where to find it in your original design. So that's the idea about the CSV file. So the CSV file is a description of the column. Now, what can happen is that, so let's say I have applied a column, I've forgotten the design, and I stored it in an Excel file, the string. Then I can bring the string to your, so you open again this column file, and then you say, okay, I want to use the CSV file, so I want to use it. So when I set it on use, then you can see there is place for a CSV string. So this is the CSV string for this column that is there. And you can see, for example, that the height of this column is about 3.5 meters. So now what I can do is, okay, I say I have copied this previous CSV string, which results in this column, but I want to change this column. So for example, I want to increase the height to, let's say, 6 meters. So instead of using this 3.5 of the CSV file, I want to use the 6 meters, or let's say I type 5 meters here, and then I want to use the 5 meters that are used here. So when I do that, you can see the size of the column changing in this display. So this is sort of what happens. So the CSV data is quite important in the pipeline when you are building, let's say, a building, and you want to change it afterwards. So that's why I created these files, but it means that you also need to have like a setup where you can work without it and with it. So this menu is adaptive, which is quite interesting. I did some study, and it's possible to make an adaptive menu. So what you can see here, so if I say ignore, you can see that all these booleans that are here, these on and off switches, disappear. So when I click on ignore, then you can see this menu gets really cleaned up. If I use this, then you can see the menu becomes longer, and I even need to scroll in this screen setup to see all the possibilities. So you can have two different menus. Let's say parameter screens that are based on the choice that you make in your menu, which is very cool. And it gets even better, because what I didn't expect, but it turns out to be possible anyway, is that you can have groups that are using, let's say, this menu setup, that are the same groups as are used in this menu setup. So you can feed different data, let's say original data or CSV data, through the same groups, and that sort of with that you avoid that this group needs to be, that you need to build this group twice. So you can have just one group feeding through these two menus, which saves a lot of work and makes your setup also a lot cleaner. So that is a good thing, and that was not easy to find out how that works exactly. Now I can also show you some other things. So the menus are made in this group, and they are also made in this group, and they are also the same. So you can see that the menus that are generated here are, and these are not all the menus, these are several of the items where I use a menu. For example, this is done with a menu, this is done with a menu, but transparency is not done with a menu. So not every item is a menu. And you can see what I'm doing here. So for example, here you can see I have these three groups, Corinthian, Ionic, and Doric, that you see here. And you can't set the way it is presented here. You need to go to the let's say the highest level, where you select this group, then I select the menu, and then you can see, for example, if I go to let's say the architectural style that we were looking at. So these are these three styles. Now I can, so you have these three styles: Corinthian, Ionic, Doric. If I set this to non-expanded, then you see these three buttons disappear, and I get a drop-down menu like this. Now for architectural style, I like to have it like an expanded menu, because it's way faster to click at just a button than to go through a drop-down like this. This is a drop-down, and this is also a drop-down. I was forced to use drop-downs here because the text just gets too much, and it's too much to put it on one line. So that's why I didn't use the expanded here. I would love to have been able to do it, but it just doesn't work. Perhaps you can make two menus out of it, but that is also that will complicate your geometry nodes a bit again. So I also don't like that. And then it's still more difficult to say, okay, when you click on this menu, the button of this menu needs to close down. So I don't think if you can even make that work. So that's why I also use these drop downs here. Now another thing that that is very nice to use, of course, are the gizmos. So when you click on the item, then you can see your gizmos. I use like 7, 1, 2, 3, 4, or 6, 5, 6. It's six gizmos to, for example, to change the height of the column, which makes life a little bit more easy. You define them also here. So here you can see it's still 7. I think 7 gizmos, and yeah, let's say, why is it 7? 1, 2, 3, 4, 5, 6. I just see 6. No, I don't know why. Let me see. No. Okay, this is not a single gizmo. Oh, I think I didn't use that one in the end. Okay, so here you can see the gizmos, and you can see the same gizmos again here. Yes, so then from the gizmos we go into the data, where the data is, let's say, condensed to a single a bundle, which is done here. You can see that not everything is put in a bundle, because strings are not yet able to be, let's say, collected in a bundle. So you can put anything in a bundle except strings, which is a bit of a shame, because there are some strings that I also would like to put in the same bundle. If that was possible, I would have had only one bundle in this place. So what I'm doing here, for example, I just feed all the data through, but there is some data that I don't want to feed through immediately, because there's one rule with this column, and one of the rules is that the top size needs to be smaller or equal than the bottom size. So for example, you can see here I got the diameter on the top is 60 centimeter, and on the low side it's 80. It's, by the way, it's not the footing, it's the size of the column of the shaft here and the size of the shaft here. So, and this cannot be bigger than this. So if I would make that bigger, let's say 1.2, then it sees this is getting bigger, but this is also getting affected as well. and I get an error message, and this error message is being generated here. So it sees, okay, this one is bigger than the other one, it's not allowed, so show the error, and the error comes pops up in your parameter panel, which is here, which is very nice. So so you can see immediately, okay, I made a mistake, I need to correct it back again. So let's put it back to 1.6 or 0.6, and then the error is gone again. So that is those are the things that you can arrange. And I'd like to do it as fast as possible so that you see, okay, my input is wrong, I need to change it. So that's going on there. Because all the rest is sort of output is generated by the computer that shouldn't generate any mistakes at all. All right, so we go back one level higher to the top level. I also have a little bundle where I do some display settings. So which is based on these three, not too important here, I think. Now on this side, you can see that this input is way bigger than this input. So this bundle, there's more data going in this bundle than is going in that bundle. And what data is that? You can see that here. So besides the usual data from this panel, I can also feed the CSV data string. So the data that is here, which is a string, is being fed into this noodle over here, and this noodle is being read. So if there's no data, you can see there's no CSV data present, so he will cut off all the CSV data that might be here, but there shouldn't be any. And then you can see all the different values, which are separated by a comma, are being read. So you have the first one is the unique number, the second one is the architectural style, which is one of these three, and then the third one is the column height. So this 3.5 is indeed the height of the column. So it can use the 3.5 from this input, because this is sort of an input, and it can use the 5 meter that is here. Let me put it like neatly in 5 meters, like this. So it can also use 5 meter from here, and I can tell him to which one to use of these two by clicking these booleans. So when I click one of these checkboxes, it will use the 5 meters in the rest of the procedure instead of using this 3.5 meters. And why is this? You can imagine that you have made a design of a column that is 3.5 meters. You forgot the recipe, you went to your Excel file, then you found the CSV file, so the CSV string, then you copied the CSV string inside this this string area, and then it will use that string. But when you want to change the column based on the entire recipe that you have, then you can say, okay, I want to leave everything the same, but I just want to change the height, and perhaps I want to say, okay, and the column, the top of the column shouldn't be 0.6, but should be 0.7, something like this, and I want to change that. So then you can see it changes here. So those are the things that you can do, and you can see it uses now the CSV, this data, but not this data. And it looks a bit strange that it became so wide, but that is because in the CSV data, the size of the column was also way smaller. So if I also would check this one, then you can see the shape of the column sort of becomes normal again. So this is how you can change parameters and still use, let's say, the original settings of your column. Then you can apply it again and copy to your building file. And this turns out to be very essential in a workflow of an architect. So you sort of can't live without it, and that's because if you would make all the objects in your architectural design parametric, already this column with a fast computer, it almost takes 1 second to generate the entire column. You can imagine that if every column that you have is procedural and that you also have a lot of other objects that are also procedural, then the time it will take for you to generate your entire building will just get too long. There are some tricks to work around it. I tried them all, but in my experience, it's still not possible to do these fully procedural objects, all of them in one building file. It just gets too slow, or your system will just crash because of the massive amount of calculation that is going on the background, which is a shame, but that is sort of the time where we live in. Hopefully, when we have computers that are like 100 times faster than the current, than my 4070 that I have, then it might work, but for now it won't work. So I think that in the next few years we need to have this workaround where you build objects in a separate file, then apply them and bring them to a file where you collect all the different objects, all the parametric objects. Of course, you can have one or two still in your building file if you want to, let's say, play around, if you want to make an animation where you can see your column changing colors or things like that based on what is happening in this this file, then you can obviously do it, but to bring everything like a complete building in there is just too much. So that's why we have this workaround. And you can see we can use CSV data, but I still need to make, let's say, a sort of a specialized GeoNode setup to make to split all these this data and also apply it directly, making choices between, okay, do I need to use the original data, which is this one, or do I need to use the CSV data? So that's going on here, and yeah, I needed to build this all by hand because it's not possible to do that with the CSV importer that that Blender already has. The CSV importer basically looks at a file and doesn't look at a string. That's also a difference. It probably can work with it, but I'm not really sure. I didn't try it yet. But I already had this done before Blender came with the CSV reader, so I left it like this. Then we have the, let's say, the input managed. All the input goes to this group where the column is created. We go into that in a second. But the output of that column is sort of collected here. So what is going on here? So what you see here is that the data, let's say all the numbers that are calculated, like the volume, like the surface of paint, the square meters of paint that you needed, the amount of rebar, the weight, all these data is put in a noodle, is being separated here again, and then brought into attribute node. So it's stored on the mesh as attributes. Now, why is this? Why do I do that? That's because when it is stored, then I can make a script, and I did this here. So this script simply reads the data that is stored on the mesh. It reads it, and then it stores it in a text file or a CSV file, which is basically a text file on your computer. So then all the data that is in Blender is now in a text file, and that would be a really big request from me, is for Blender to make something like this automated, so that you have data that is, let's say, changed by your geometry nodes, that you have that data being exported to a TXT file or a CSV file. That would be a massive improvement, so that you don't need to have this step of scripting and reading the data from your mesh. But for now, this is the only way to get your data to a file that is stored on your computer, that you can just copy and paste into, for example, an Excel file. So that should be high on the list of the developers at Blender, I think. But because it's not there, this all is needed. So once Blender solved that issue, then this can be just one noodle, and we can just export data with a button from the menu, something like that. That should be nice. Okay, so now we get to the fun stuff, which is creating the column. So this was all about input and output and menus, but now we're going to design the column and also use the design to do the 2D, for example, the 2D data from the column. So now how this is done. So I go one layer deeper. So this is, let's say, the second layer of noodles, where I create the column. Now, before I do that, I also need to store several stuff onto the mesh. You don't need to store it immediately, but what you do is I prepare several data, which is, let's say, materials, paint, colors, and so anything that has to do with materials, I store it onto the mesh, or I prepare it in a way that it can be stored on the mesh. Very simple. Now, to store it on the mesh, you can see how that is done. I can see that here. So here you can see these are these color attributes. They are going here. So here you can see these, here I call them material attributes. It's the same, material attributes. And here you can see, put the color attributes or the material attributes on the mesh. So that is done here. So here you can see the noodle with all these material information, which is being split here. So you can see the type of material, the type of paint, the type of, or the transparency, color, roughness, all these kind of things. Oh, this is the opaque material. I use two types of materials, transparent material and an opaque material. It has to do with also some issues that you might have when you use transparent materials. Sometimes if you have a lot of transparent materials, which you will have if you use this kind of technology, then you get issues with that you have too many, let's say, transparent layers on top of each other, which can look very, very strange. So to sort of to fight that, you can, what I always do is I use also a fully opaque material that is used when there is no transparency used at all. Because even when you set transparency to 0, it still happens that I think it's in Eevee. I don't know. In Cycles. I don't know for sure. It's in Eevees also, but you will see some issues there. So that is done here. So, and when these attributes are stored, so you can see I store 3 of them. So one is called menu color, one is called menu roughness, and one is called menu transparency. So now when I go to the shading tab, and for example I choose the procedural, let's say marble. Here we have marble. Let me. Yeah, then you can see these 3 attributes being selected here. So you see menu transparency, menu roughness, and menu color. It says menu because these are the values that are set in the geometry node. So not in this menu, but if I go to my geometry nodes, you can see here you have your material, you have your roughness, you have your color. Oh, this is your color. Sorry, this is your roughness, and your transparency. So these 3 items are set here in geometry nodes, and then through these attributes, they are brought to your textures, and these textures are all full procedural. So this is a procedural marble. You can see there is no texture. Let's say there's no image texture used. So all those textures are made procedural, and because they are procedural, you can also sort of bring in the colors, bring in the roughness, and bring in the transparency as variables that are going into this mix and brought to a result. So you can do that. So when I set this on custom, of course I need to go to my, so you can see it's like green, so it's greenish here, but if I make this more, let's say red, then you can see my color changes. So this is done in geometry nodes, and you can see there's nothing changes in my texture, but still my column changes because it uses this attribute. These attributes are used to steer the procedural materials. So all the materials that I use in my column are therefore also procedural. So no image textures are used because of this. Okay, so let's go back to my geometry nodes. So that is done here. Let's go back here. So in the beginning of the construction, let's say of the drawing of this column, I arrange my materials. I can add these materials to my mesh immediately, which is not done here. So well, it's done here, but it is done only for a few exemptions. In reality, for the column itself, the colors are set in here, so you can see the material attributes going in here, meaning that when and these are the three parts of the column. So this is the capital is done here, this is the shaft is done here, and the base is done here. So these parts are drawn here, and they use the input from here. These are basically the bundles that I had, and I separate the bundles. Sometimes I change them a little bit, or I read them before I use them, and then we get into these procedures. So I think we can go there now. Okay, so draw the capital mesh. So this is the procedure to draw the capital. Now, if I go to the viewport, this is the viewport. When I switch off the geometry nodes entirely, like this, then where is my? Oh yeah, that's very strange. Let's do it here. I don't know why that is, but in geometry nodes you don't see the base mesh, and you can see it here. I still need to figure out why this is. So if I oh Jesus, it's also not here. Okay, well, just to do with the, I don't know why this is. So here I can see, so this is the base mesh that I use. So this is basically, before I start to build my geometry node tree, this is the mesh that I have. I used to have it smaller. I wanted to cut it in 4 or even in 8 parts, because it's like it can be copied around its axis. But the problem was that I didn't get it manifold, and that's because the details are so high. That's my theory, at least, is that even if you sort of melt it together, it still finds some non-manifold parts in it, and I just can't find where they are. So I've been searching for like a day to see where these manifold errors were, but I couldn't find it. And it's very nice to have manifold items to start with, because when you do booleans, and you do a lot of booleans, I will show you, manifolds are way faster than the other solvers for booleans. So if I want to cut a, let's say, a hole, like to put a tube in this head, this column head, then it would take like 5 times more time to do it if this column head is not manifold, or if it is. So that's just the way it is. So I couldn't work around that. Actually, I started with 1/4 or 1/8, and I decided to bring it back like this. For some reason, this, let's say, the ionic doesn't have this manifold issues. So when I double this and double it again, and I merge it together, then this is perfectly manifold. So that's fine. So I left it like this, just to keep the base file small. But because you can see there's a lot of detail here, so the base file is like, I think 14 megabytes, of which 10 megabyte is just this mesh. And the massive GeoNode tree that I built is only like 4 megabyte. And it's a bit, let's say, it's a bit, you get a bit, how you call that? It's a bit deceitful, because you think, okay, your node tree is only like 4 megabytes big. So it should be quick, but if you put a few booleans in there, then it really gets fast or it really gets to be solved in like a second, or a little bit over a second, or a little bit under a second. So this the size of your node tree doesn't really matter that much. It's about a lot is about the booleans that you put in there. So let me go back to my geometry nodes. So to check this, you can see I put these timestamps in it. So now you see there are no. Let me go back to this one. You can see that the it's actually, oh wait, this is still off. That's why it's so fast. Well, you can see it's still fast, but you see, for example, here, so to create the shaft is not too much time, but to add the duct and to and which is a boolean, this costs already like 200 milliseconds. So that goes quite fast. So and this is the column head. So the column head is like 260 milliseconds. The shaft is 180, and the base, there is not much going on in the base, so there's just 17 milliseconds. And these times are fully based on the booleans that you have. It's like 95% or even more is caused by the booleans. So now let me go into this in this noodle, or this group, where I create the head. What you see here is that basically the base mesh is being separated and shift to the 0, 0, 0, 0 location, and that is done for the head, and then the head is being moved up to its top size, which is done somewhere, I think, in the back here, but I'm not sure. It's probably a bit earlier, somewhere here, I guess. I think it's here. It's being, yeah, you can see this is the capital start, so this is where the Z of the capital starts, and then it's just transformed to that place. What is going on here is that yeah, the shade smooth. So another issue that is quite difficult in geometry nodes is to get the smoothness of the object. So for example, this column head, you want to have a very straight top, so this needs to be fully flat, but this part needs to be smooth. And then you have the bottom of the, which is here somewhere, also needs to be sharp again. So how I always work is that I use 2 shade smoothers. The first one to make everything shade smooth, so everything gets sort of round, and then I make a selection of all the parts that need to be straight. So the bottom part and the top part, they need to be selected, so that's going on here. And then you can see, instead of being shade smooth, it's the shade smooth toggle is switched off here. And I use the faces, so I select the faces, so the top face and the bottom face, and then I say, okay, these two you need to shade flat instead of smooth, which you do like this. And then only this way works for me. So only then you can see the nice round features around these details. So you can see that this is very nice and round, no edgy stuff going on. Also these little spheres are quite nice and round, but the top is still flat. And all these details, you can imagine that if you want to make your own procedural column, it just takes a lot of time to get all these details right, and to see, okay, this boolean works, this shade smooth setup works. So you need to have quite some experience to get this done in a proper way. So once it's put in place, then you can see here I put the attributes for the colors on this mesh, so which is done here. So I get this bundle where the material attributes are. I put it on there. It's the same procedure again. So I think you can see I use it 25 times in this column setup. So you can imagine how many times. You only have 3 of those, of which and then the column is like separated in 4, but still you need way more of these groups, because you can imagine that you have a group for this type of column head, but you also have, for example, because this one was the it doesn't say it in the title, but this is the Corinthian capital. This one is the Ionic, and this one is the Doric. So, and each one has their own way of selecting, because these heads are not the same. You have different, let's say, selectors to shade smooth and shade flat the specific column head. So that's why it's done in 3 separate ways. So you can't use the same group to shade smooth, let's say, the column head. So now then it comes together, and you yeah, so okay, and then it goes out like this. Then when everything is done, what I also do is that I calculate the volume. So the volume of the entire column head is being calculated here, and the surface. Now the volume, you can imagine that to calculate this volume is quite complicated. So how do you do such a thing? It's and luckily there are some very smart people that know how to work with like cross products and dot products and vectors and stuff like that. So this has been part of my research to find, let's say, people that made, let's say, proper, fast ways to calculate the volume of a column head like this. And then I tested it and checked it, so to make sure that it's accurate, and only then I put it in there. So these are sort of little gems that you can find in my setup. For the area to calculate the surface of the entire column head, they're simple. You can simply use one of Blender nodes, which is the attribute statistics. You set it on float and on face. You just feed the geometry in it, and it gives you the surface. So this is all done with the preset Blender settings, which is nice. But Blender doesn't have, let's say, a proper volume node yet. So I would advise them to just copy this one and just provide that one for our users. Obviously, this needs to be also properly manifold. So when this is not manifold, you will get errors, and so that's why it's important to make things manifold. Okay. So that is that. Now the same thing, of course, for the shaft. It goes like this, but the same thing. What's happening here is that it's scaled to size. Then we make a curved line out of it because the column consists of drums. You can see these lines here. So this is one drum. So I make a curved line from here to there to make sure that in the next step these parts are being generated, and which is done here. Sorry, no, that's not right. Need to go one higher. Oh, this is no. I need to go one higher. Yeah. So this was the column head. So this is when I go to the shaft. So, and to create the shaft, so you have the same thing in the beginning. So the same setup to let's say to position it, then to create a curved line out of it, and then this curved line is used, and that is done here, to cut the segments. So when this column is, let's say the shaft of the column is created, then I just simply cut it in segments, and that is also done with a Boolean, which is, you can see here. So this is the mesh Boolean, which is a difference. And once we have these different parts, then also a lot of work still needs to be done on those parts. For example, then there need to be, we need to measure them. There need to be this piece of glue in between. The color needs to be applied, and also the volume, and all these volumes, and the surface area needs to be calculated. And then we need to put a shaft in it for the duct. Sorry, we need to put a duct in the shaft. And we also need to draw the rebar. So this is all done per segment. Here you can see how this part is. And let me just take an individual. If I put this in like -4, I think, then you can see. Let's put it on 4. When I put it on 4, and you can see this is a single element. So here you can see the rebar, all these holes in it, which are done with booleans. So this is all done in here and calculated. So the amount of rebar, everything is calculated here. But what you also see is that this one has this profile. So with round profiles cut into the surface, which I can do with this part. So I can make it flat like this. I can make it square and concave, and I can also make it convex. So, and that is done in these groups. So, and I can even twist it. So when I put this on, let's say the twist factor, if I put it on 1, then you can see that this is even twisted. This stuff all happens in these node groups here. So I have the square one is done here. This is square, yes, square curve line on a square column. Then I have a square curve line, and I think this is a round column. I'm not sure. Yeah, and I can, yeah, and these are combined. So here I can have round and square columns, I believe. Yeah, so I have a round column. These are going on, no, the round columns are here. These are all round columns. You can see it. So the round column is fed in here. And then in this group, these profiles are sort of cut out. You can see how that goes. So, which is also a repeat zone, because I need to repeat all these profiles around the round column. So you have a repeat zone where you can also see the Boolean. So you make, let's say, a shape here, and then that shape is being cut with this repeat zone. So that is that one. And again, these are, let's say, you have different types. You have square columns. This one. So this is drawing, let's say, the square column. And then here you can see the repeat zone where the profiles are being cut out of a square column, which is a different procedure than when you cut it from a round column. Because you need, if you have a square column, you can see it here, a square column, then you have, like, say, a repeat zone here, 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 and here. So this is how that goes. And obviously you do that in a smart way, so you don't need to do it 4 times. And also the twist factor doesn't work on a square column. Okay, so that is the shaft. I think there's not too much more to say here. So let me go to the third part, which is the base. Well, the base is a bit simpler. The base is just it gets drawn. So here I draw the base. Yeah, so I have 2 bases. So one that is square and one that is round. So okay, let's continue here. So we were at this the straight columns, which are generated here. And you can always see again the volume calculated, surface being calculated, and the colors being put on the mesh. And also shade smooth being arranged, which is also for these elements obviously important. Okay, so let me see. Yeah, so and each time, which also applies for the column head, is we need to draw a duct if it's used, and we need to use the splice sleeves for the rebar if it's reinforced concrete, precast concrete, or we don't if it's just regular concrete, or none if it's like limestone. So that is also done, and that is done here. So first we create the mesh without the holes in it, and then we bring the mesh or we create, let's say, and that is the, let's say, the you can a curved line. Here you can see the curve of the curved circle. So this is the mesh that is being used to cut this hole in this element, which is done here. So the boolean, let's say the boolean is created here, and then here it's being cut out. So the duct is being cut here with the boolean, which you can see here. I also use these workarounds. So if there's no duct, which is also very important to speed up your mesh, if you have a boolean where you cut out something that doesn't exist. So if you have, let's say, if you have no boolean to cut out and you still use a boolean mesh, this will take forever to solve because it doesn't know how to deal with that. It also looks a bit like a bug in Blender. It should be, let's say, a boolean should notice if there's nothing, and if there's nothing it should do nothing, but apparently it can't deal with it. So that's why I make this workaround literally, and I put the switch in behind. So if there's nothing, then this operation is not used at all, just to speed up the node tree. Okay, and then also separately the rebar is being created, which is even a bit more complicated than the mesh. So the first thing what I do is to create several curve lines, because the rebar is not going only like this. Let me show you a little bit how rebar looks like. Let's put it on concrete precast like this, and then make it transparent like this. You can see that the rebar is not only going straight into the sleeves, but we also have rebar going around like this to bind everything together. So and these are I call them horizontal rebars. So you see the top, outer, third, second, and first. So that is going on here. So it's always like if you have a segment, there are only like 4 ropes going around it to bind it together. And again, in the end, these columns should be checked by structural engineers. Okay, so then for the rebar, we have special material that is not procedural, because it's always the same. So there's no, let's say, parameters that you can change for the rebar material. Let me see. The material is coming from somewhere else. Yeah, you can see here we choose, let's say, procedural rebar horizontal. So it's put in here. I could also have put it inside the group itself, but yeah, sometimes these things happen. I could clean up this a little bit, but it's not too important. Okay, so that's where the material is chosen, and for the rebar, this is also procedural. So you see these lines. If you have horizontal mesh, I use a different texture than when I use a vertical one. That has to do with angles. You can see that in the corner, this material doesn't look too great. And to sort of reduce this as much as possible, I use two different materials, one for vertical rebars and one for horizontal rebars. That's why you see horizontal rebar in here as a material. Okay. And obviously all that rebar is also counted. Yeah, so the cubic meters of concrete, or the cubic millimeters, let's say, are counted, and then also collected for every segment altogether, so that we know how much kilos of steel are being used in these columns. Okay. You can see here that we don't put it together, so we don't join the mesh, because I also want to do separate thing with the separate types of mesh later. Especially when I have these 2D drawings, I also want to separate the mesh from let's say the rebar mesh from the let's say the concrete mesh, or the material. So because I want to show let's say in a different drawing only the rebar. So that's why I don't combine it, because if I would combine it, then I should separate it later again based on the material properties, which is just not very handy. It's easier just to keep it apart from here. Okay, so that is how these three elements are being created. Now we go to the 2D representation. So I put this on 0 again. I set this on a detail sheet. I need to bring back the transparency to 0. And then I set the this already done. So now I need to set the camera properly. So now I have this stuff going on. Now this entire thing over here is being created by this group, which is called datasheet. And this datasheet is you can see that almost all the data that is collected is being fed in here. Also all these text, because all the text is sort of represented here. You can see the amounts, but you can see also words like section, and you can see all the text that is used in the, let's say, in the parameter sheet here is being sort of repeated here. You can even see that the color, which is just a color in here, is also being copied here. Let's see. I don't know why it's not the same. Yes, I don't know why this is. Let me go back to the default. So this is the default color. This is the custom color. And this value should be the same as this value, but it isn't. And I think it has to do with the darkness. So if I make this lighter. No, I need to figure out why this is different. So, but that is, and it shouldn't be a bug actually. So there should be a reason for this. I will come back to that later. Okay, so let's continue. Let's go here. Now here you can see also a lot of subgroups. So in this group, I just create the amounts, which are here. Which is also quite a big, complicated group, which uses a lot of text. And so here you can see the text coming in, and being sort of distributed. And these are the lines. So this is the first line, second line, and this is done in a loop because it could be that there's no rebar, and when there's no rebar, then this should be more condensed. So this should be more condensed, and this loop arranges that the empty lines can be left out. So for example, if I put it on marble, then you can see that the rebar will disappear, and here you can see, and that is arranged here. So that's why you have these this repeat zone going on here. A very important one is the camera. So actually I need to go back to not even to this one, but even I think I saw it here somewhere above here. So this is where the camera is being set. So, and that has to do with the size of the column. So the column is normally in this position. The original mesh is normally in the 0 position, which is here. But it just for layout purposes, when I set it on the detail sheet, then you can see the original column shifts from this place to this place. And the camera adjusts its size to the height of this column. So if this column is bigger, then here the size of the camera will be changed, which is very cool. So because that makes life a lot more easy, but it also means that everything needs to be scaled. So all the lines, the line thicknesses that you have here, everything needs to be scaled to the size of the camera. So that's why I do it sort of in the beginning. And it takes the camera position. So how does it? So here you can see that it takes the size of the column, and it stores it. It also stores it in as an attribute. It's called camera transform. And what is going on with this camera, and I can show it here when I select the camera. I used how you call it, a driver. I use the driver to scale the column. So what is happening is that I store the value on the mesh, and then I can access that data to change the size of the camera. So that's how I pull this one off. So it is not, you're not possible to use the camera let's say details, because you get into a loop. So because the camera is depending on the size of the column, and the drawing is depending on the size of the camera. So that created a loop, and the only way to work around it was using this this stored attribute, and then work around it. So that's going on there, and then that data is being used. So you can see that that is mesh. Let me see, where is. So once the camera is set, then I get the camera position here. So I take the column height, and then based on that, I just create a vector with the X and the Z position of the replaced camera, and then I move the camera back 10 meters to create space where I can look at these I call it at that sheet. So, and this sheet consists of several layers. So you see the layers over here, And then you can see, where's the camera? It should be, why is it not visible? I don't know why I don't see the camera now. Well, the camera should be here somewhere. Here you can see the camera. I don't know why I don't see it. See it here. No. Okay, so that's the camera, and then you can see that the position of the camera is being fed in all these in all these groups, because every group needs to sort of adjust the size of the text and the size of the lines and the thickness of the lines to the position of the camera. Which are sort of scales. So you can set a scale factor, and then you use that scale factor. And that is used, for example, in the sheet layout. I think it's here. You can see the position of the camera is being fed here, and then you can see that that is used to determine how the text and the lines are being positioned on the sheet. So if I go through these groups one by one, sheet layout, this is the this is basically to set the line spaces between these lines here. Now the second group, these are the sheet lines. So these sheet lines are the lines going around here. So this line, this line, this line, this line, all these lines are being created in this group. So these are just a bunch of lines being drawn. And you can see that these lines are not just a line from point A to B, but I also need to take into account the thickness of the lines. So it's basically every line. If I look at a line like this line has 4 points. Let's say 1, 2, and then 3, 4. Because in Blender you need to give every line thickness. And you can see I use different thickness. So these lines are a little bit smaller than these lines. Now here you can see the sheet parameters. These are the sheet parameters. The amounts are these ones. These are the amounts. So that is arranged here. These are the lines. These are the parameters. Now the parameters don't have a repeat zone, but you see 1, 2, 3, 4, 5. These are all these lines are over here. And here you can see where all these text is being combined. And sometimes, for example, if you have like a flat column, then you don't have this line. So if I put this on, say if I put this on flat, then you can see that, am I right now? Something that doesn't work now. Okay, this is wrong. So this should disappear now. So I don't know why it doesn't disappear. So that is probably a bug that I need to check. Okay. Then so, and if I go to one of these text boxes, then what you can see here, and this is always the same. So text goes in, you can align it to left to the right. So that is done here. So it's aligned to the left or to the right. And I also made a procedure for uppercase, because sometimes words, you want to present words in uppercase and there's no Blender procedure for that. So I made quite a big procedure to make every letter uppercase. So I hope Blender will also make one for those. So that's how to present the text. Now then there is a very nice procedure to create things like this. So this is done with, so what you want is you want to have sort of line art that only shows the front of your column. And to do that, you need to raycast let's say the lines that you have here. So this is also one of the gems that I found to make a proper, let's say, 2D impression of a front of a column, which can only be done by raycast in let's say a simple manner. If you wouldn't do it with raycast, then you would have need to create the full column head procedural. So all these curves and round things and items should be done procedural. Only then you can make a 2D representation from it. So the only workaround you can have to create, let's say, a view like this, which looks like 2D, is when you use raycast. And this procedure I encountered on the internet. Somebody had a podcast how to, or let's say a tutorial how to do this. So I copied that in there. So that is that part, the line art. Then I have a section. Now this section, this is a section AA. So this is section AA. And you can see these section procedures, they are quite big. Because a section consists of a lot of stuff. So you see, and this is how you sort of translate procedural data to 2D data. So which you need to interpret it, everything, and then make layers out of everything, and then create also the text that goes with it. So these amounts, these measures, so if I put it, for example, on concave, these measures all are connected to this section. So a lot is going on. So you need to make these curves again. So everything needs to be done again, basically, to create this section. So, but I still did that and all this work to show that if you have a 3D representation of something, you can make any 2D representation procedurally. It only becomes difficult if you start with things that are not procedural. So as for example the column head, which is done which is just a mesh. And when you have just a mesh, then you can get in trouble with 2D drawings. But with the 3D, when it's fully procedural, then you can always create something like this. And I can go even further. I can even make more measures here if I would want to. But it's just more time, and I don't think it's really necessary. So I think I made my point doing it like this. So that are the okay. Let me go further. So that was the section. For the other section, I just needed a contour, and the contour is also made by line art. It's sort of the same procedure as I did here, but then only with the contour. So I simplified I don't know if that is here. Yeah, the curve was already, so the curve has been made outside. Oh no, actually, yeah, I think it's still done like that. So let me see how the column head is done. So this is the capital. So here you can see the capital, and then let me see. How did I do that? think it's done earlier already. So yeah, I don't know. I need to search a little bit further. I don't know exactly where I made, how I did the contour of that one. So then with all these contours together, then you fill them up with these 2D textures, which I made, which you can simply find. So for example here, these are the 2D materials. For example, this one is concrete, and this one is, I think, wood. Yeah, see, that's wood. So, and you can find all these materials in the shading, under the shading tab. I also made them all the materials. I made them fake users, so that they all are saved. So even if you don't use them anywhere, then they will never be destroyed if you clean up your mesh. So that's also quite important, I think. So all the materials, make them all fake users, because everything is procedural, and which can mean that you don't have all the that you don't use all the materials, and when you clean up your mesh, then it could happen that you lose your materials. So that's why it's important to make fake users out of them. Fake users means that even if it's not used, Blender looks at it as if it's a used material, so it won't delete it if you clean up your mesh. Okay, so that's that. Now I think we're almost through. Yeah, so the rebar is also drawn. Let me show it here. It's here. So when I have this rebar, you can see it appears here. And this is also line mesh or line art. So I use line art to draw the rebar. And of course you can put a lot more details in here if you want to, but again, that's just a lot of work. And again, I made my point, I think, by showing it like this. Okay, so that is my node tree. It's quite big, but the nice thing is that the procedure to do this, let's say how you connect materials to your mesh, how you work with the CSV string, how you can generate 2D data from 3D, which kind of procedures you need for that, how you work with text and translations. All these things are now sort of solved, and it could be that Blender provides some better nodes or some additional nodes so that we can do things more easy or with less nodes. But until that, we probably we will use these nodes. And so any next material that I create or object that I create, any new asset that I create, will have this same sort of workflow. Input, output, generating mesh, and then generating a sort of output sheet, 2D sheet, where the information is being displayed for people to use. Okay, I hope you learned something. Please share and like, as they always say. And I hope to see you in the next one. Goodbye.